All right, this is 7-4 day 1. Topic is reference angles. We are going to use reference angles to help us evaluate angles, sine and cosine values. All right? Really two characteristics of reference angles that I want you to pull from this. Number one, they're always acute, meaning they're always between 0 and 90. And the second piece is that they are formed by the terminal ray, or the terminal side, and the x-axis. Okay? Acute, formed by the terminal ray and the x-axis. Okay? Every angle that we could plot on a grid, really on a unit circle, you could say, from 0 to 360, actually well beyond 360, any angle has one. Okay? They all have reference angles. And they come in handy in terms of finding angle sines and cosine values. It can simplify it a little bit. Okay? Now, if we have an angle that's in quadrant 1, that whole situation kind of lends itself to being set up with the right triangle. So those have reference angles. They're just the same as what they are. Okay? I'm going to write down a few examples here right off the bat. How about one that's in quadrant 2? That would be an angle. It looks like that. Okay? The reference angle is right there marked in black. And think about it like we would set up a right triangle and use that angle to think about some sine and cosine values. Now it's worth noting that the two red sides, that forms angle theta. Okay, that's the angle that we're talking about, and because it's in quadrant 2, I know this angle is somewhere in between 90 and 180 degrees. But it has some very, very particular relationships with this reference angle in terms of its sine and cosine values, and I can use that reference angle to make it easier to find them. If we were down in quadrant 3, okay, here's our initial side, that never moves. This angle would be down here. Okay, there it is, that would be theta. And again, in black, I will draw in the reference angle, which is right there. Okay. Again, formed by the terminal side and the x-axis, and it's always less than 90. What if we were down in quadrant 4? There's our initial side. There's our terminal side. Okay. Here is angle theta. This angle is somewhere between 270 and 360 degrees. There's the x-axis. There's the terminal side. There is our reference angle. There's our reference angle. Okay, I'm going to start to look at some specific reference angles, but right now we're just talking about the general concept. But again, that's where we're headed right now, is let's put some numbers with this. We want to rewrite, in some manner, the sine of 695 degrees. Now the very first thing I want to do here is use coterminal to get this down to something that's between 0 and 360. So it's a little bit easier to mark. When I take away 360, I get 335. Okay, so 695 degrees and 335 degrees, those are coterminals. Okay, so here's the initial side. Bottom line, what this means is we're down in quadrant 4. That's where we are at. Okay, we're down in quadrant 4. Now technically this angle of 695 would go all the way around and then come back. Okay. In red I'm going to mark the reference angle, and I'm going to kind of go off of 335. Okay. This is 335 degrees. What I'm really interested in is what is left to get to 360. Okay, because in red that is the reference angle. And in this particular problem, the reference angle is 25 degrees. And the reason I got that is 335 plus 25 equals 360. Okay? That's how I got it. Now here's the important thing about a reference angle. What I can say from this is that the sine of 695 degrees equals the sine of 25 degrees. Kind of nice, okay? Except for one thing. We have to think about sign. Not like the sine ratio, like positive or negative sign. We got to pay attention to our quadrant, okay? And here's what I mean. Remember that cosine values on the unit circle are always associated with a point's x-coordinate. Yeah, I'm talking about the point on the angle, the point on the circle that forms the angle, okay? Sine values are always associated with the y-coordinate. Now here's what this means. In quadrant 1, everything is lovely. All the coordinate points up in quadrant 1 are positive in terms of x and y, which means sine values are positive in quadrant 1, and so are sine values. Now over in quadrant 2, we start to go to the left, and here cosine values are negative, but sine values remain positive because we're still above the x-axis. Okay, to get to any point on the unit circle in quadrant 2, you go left and up. So negative for cosine, positive for sine. To get to quadrant 3, you have to go to the left and you have to go down. Both sine and cosine values are negative in quadrant 3, and that finally leads us to where we are, quadrant 4. Okay, so to get to this point on the unit circle, I have to go to the right and I have to go down. Well, going to the right associates us with positive cosine values. Going down is associated with negative sine values. Okay? So the sine of 695 degrees is equal to the sine of 25. Okay? And remember that reference angles are always acute, always less than 90, which means reference angles always come from quadrant 1, where everything is positive. Okay, so without even evaluating it with a calculator, I know that the sine of 25 degrees is positive. But we're down in quadrant 4, where sine values are negative, so I do need to just throw in the negative sign. Sine of 695 degrees equals negative sine of 25. Let's look at a few more. Okay. Cosine of negative 210. We want to rewrite that expression as a reference angle. Now, the initial side for these kind of problems never, ever move. Okay, they never move. Here it is. Now, 210 means open up clockwise. Here's 90 degrees right down there. Here's 180. There's 270. 210 should take us slightly past 180 degrees. Okay? So there's the angle that we're talking about, negative 210. In blue, I just marked its reference angle, which I want to be able to put a number with. Can't quite fit it in there, so I'll just put an arrow. The reference angle that we're dealing with is 30 degrees. Okay, that's because to graph negative 210 degrees, or to draw that angle, I had to go 30 degrees past negative 180. So what that means right off the bat is I can say that the cosine of negative 210 degrees is equal to the cosine of 30, except possibly in terms of sign, positive or negative. This could be negative. Okay? We are in quadrant number 2. Okay? Go back and refer to that previous page of notes we just took. Are cosine values positive or negative in quadrant 2? Okay, that's the big question. They're negative over in quadrant 2. Remember, this is a reference angle. It's always less than 90 degrees, which means cosine of 30 I know is positive. So I do need to adjust that and say negative cosine 30. Okay. 820 degrees. Always nice to think about coterminal angles. Let's subtract 360 here, because I really want to know what quadrant I'm in, and it helps to get some coterminals. for 60, after subtracting 360 once, that didn't do it, so I subtracted again. And so it might be easier to think about this in terms of a 100-degree angle. Okay, and in fact, if I wanted, I could say right off the bat here that, sine of 820 degrees is equal to the sine of 100. Okay, now what that tells me to do is draw in my initial side, then I can draw in my terminal side, which is just past 90 degrees. Now, if I want to be technical here and mark 820, this means around, and that's how it would be. It's kind of silly, but that's how it would be marked. Okay, we go to 100 degrees, and then we do another 720. Okay? Reference angles in blue. Okay? Take a second, see if you can figure out what the value is of that reference angle. It happens to be 80 degrees, because what I was thinking about is the fact that 100 was a coterminal. That's why we went slightly past 90 degrees, and we're 80 degrees short of 180. Okay? So right off the bat, I can write this in and say that sine of 820 degrees equals sine of 80. Okay? We are in quadrant 2. Okay? Again, I know the sine of 80 degrees is positive. Comes back to our sine values positive or negative in quadrant 2. They are still positive. So I do not add a negative sign. Sine of 820 degrees is the same as the sine of 80 degrees. Quick word with the calculator. I'm not going to spend any time on this. We can talk about this in person if you missed it in class. It's really straightforward. Okay, we can use the calculator to give us decimal approximations for sine and cosine values. Just pay attention to the sign. Notice those don't have a degree symbol, so they're in radians. We pay very close attention to if it's in degrees or radians. And the one thing you have to watch out for in the calculator is there's you can change the mode for your calculator to interpret angles as degrees or radians, and it's important to be in the proper mode if you're going to use the calculator. Okay, that's something we can talk about more in class. It's not very complicated, but just an easier topic to deal with in class. We'll call it quits there. We're not done in 7.4. We have a few more things to talk about with the sine and cosine functions, but we'll get to that in 7.4 day 2.